Hi, this is a short example on how to disassemble these e-paper display price tags and how to change the PCB inside of them to be used with an Arduino or a blue pill board or any other board like this, ESP32 and so on. We need first of all a big flathead screwdriver to open up the case. The case itself is not glued, but it has some really tight clips to get rid of it. There are 3 on the short side, 3 on the top side, on the long side. And we need to get into the sliding part between the display and just press in and turn the screwdriver around while doing so. This one was already opened, so it's a bit simpler, but in the end you will have here a bit shorter opening or a bit wider opening, and we do the same on one of the long sides, so we have 2 sides open. Then we can put the screwdriver away and bend the whole thing a bit so the other clips are forced out of their position, so we don't need to use the screwdriver there like this. As said, this was already open. It can happen, as you see here, that some clips do break, but that is the reason why I only do 2 sides with the screwdriver to not do too much damage. We now have here the display, the flex cable to the display, the PCB, and our main goal is to remove this shielding, remove these 4 resistors, remove the main chip under the shielding, and solder wires to it so we can access the SPI bus of the e-paper display. This is done because the step-up converter is here integrated on the PCB, and that way we don't need an extra PCB like this, even if it's doable, but if we already have it, we can reuse it. To get the display out of the front, we can bend it a bit so we can get our hands behind one side of it and pull it gently out of the case so we have it separate. We now also need to remove the PCB from the display itself for the reason we want to heat this PCB up quite a lot. So we flip up the FPC connector, pull out the flex cable, and now we need an X-Acto knife like this one, and we need to get between the PCB and the display. You have to be very careful here at the flex cable, as this can be cut quite easily, but the back is not so brittle, as is a separate plastic layer under the display, so you don't can accidentally destroy the display. Even if you do it hard enough, then maybe. But we cut through the PCB and the plastic layer to get rid of this glue part, so we have the PCB on its own. Now we put the display away to have it in a secure place, and we take care of the PCB. To remove the shielding, I will use a hot air gun. This is a 998D Hulko or something Chinese brand, and I will heat the shielding up quite a lot because the ground plane is quite hard to get hot. I will set the hot air to maximum and the airflow also to maximum. But this is just for the shielding, so it is a bit easier to get it apart. I will now also use a tweezer to get the PCB, the shielding away without heating my fingers up too much. I'm just sticking it around the shielding and heating up the shielding around. And every now and then I try to pull the shielding up with the tweezer. This is maybe a bit loud for you, but I hope you don't mind. So I can already see that the solder is getting apart, and I need to heat the other side a bit more, but it looks quite good already. So yeah, that's it. I moved the connector here a bit, and I will now turn the airflow down and the heat to around 340 degrees, and will remove the main chip already, so we can use the heat we already brought into it, and we don't need to reheat the whole assembly. So I removed the chip like this. We can also remove some excess parts that are here around this area, as we don't need them anymore, like the oscillator, for example. It's just not needed to get the display working. Everything we need is around this place. So we also remove these 4 resistors at the beginning here. These are for the SPI lines, and these are reset and CS, so chip select for the display, like this. And now we can turn off the hot air station, and the rest is done by soldering new thin wires, in my case 0.2 millimeter. So here I have prepared one PCB with all the necessary wires. I will link a picture of a precise description of what wire what is, but just to show it a bit, this is just the simple ground wire. This is 3.3 power. Then we have here the BS wire. This is going from ground to pin 5 of the chip of the MZ100. It's the display BS. So 1, 2, 3, 4, 5, and then you can simply count the connections from 1 to 5 and solder one thin wire to the ground plane. That way the display knows it should be in 3-wire SPI mode. It is hardwired, as we never will use the 4-wire SPI mode. Yes. Then we also need to solder 2 wires here that are the hardest part of everything, I would call. It's for once the 1, 2, 3, 4, 5 6th pin in this row. It's the DC pin of the display. This switches the SPI between data and command. So data would be display data, so an image data, and command would be something like go to sleep or wake up or refresh the display now. Then the 5th pin here is the buzzy wire. This is an input coming from the display to say the MCU yeah, I'm ready with my refreshing, I'm ready with whatever I should have done. So we also need to have that. These are these two wires to solder, and also we have the 4 removed resistors here. And I also got the pinout a bit sketchy but useful. So the top resistor here, where the top resistor where, this is the master out slave in coming from the MCU to the display. Then we have the SPI clock as the next pin. Then we have the CS pin to the display, so the display knows the SPI command is for its purpose, so it can use that. And also we have the reset pin to the display, so we can just reset the whole command set. And yeah, that's overall every connection we need. This can maybe wired to some pin header and glued to the PCB, but as we have only a bit amount of room in the case, we can maybe even bring it out here, as this is an opening in the case, and just close via the sticker here. So we could use that to get the wires out, make a nice connection here on the back, and close the case again. Maybe even use the batteries that are under here. I will quickly show how to get there, as it's a bit annoying. So we first have to press in here and pull the battery part to that direction, and also we have to lift up with this slot the battery pack, and then we can try to get it over like this. And now we have the battery case open and 3 2450 3-volt batteries to maybe work with if you want to put a small MCU inside of the case to use it directly, like an NRF 52832, which would be great to have. While I was soldering, I midway changed my mind to already solder a pin header here to make it simpler to show right now. I choose the same pinout for the adapter board I designed, so the 3-volt SDI, so MOSI, clock, CS, DC reset and busy, and the ground pin. So I have it exactly arranged like this, so I could simply unplug the wires and plug them here in again. Short words to how I did it. I first pre-tinned every pin of the pin header. We need 8 pieces, 8 counts, and I removed a bit of the solder mask here, so for once here at the 3.3 volt rail and around here for the ground plane, to have a nice holding place for the pin header like this. So for once here 3.3 volt and for once here ground. You have to be careful here on the ground and the 3.3 volt rail, I would call it, connector, to not short your soldering there. Maybe put a bit of Kapton tape, and then you can simply route the wires to the pin header if you want to use one. We can now connect the display back again. For this we pull up the lever and slide the flex cable connector into it. You need to be a little bit careful. It should slip right in, but sometimes it's a bit harder. You can maybe wiggle it a little bit around to let it go in. I pressed it a bit back onto the glue. It will not hold that much on there, but yeah, we will leave it like that for now. And you can already see something on the display that was shown there before. And I will connect the power to the ESP32 board like this. It is running the GXEPD2 library example with the standard pinout for the ESP32, and I will simply plug it in and you can enjoy the show. As this is a 3-color display, it will now not do the partial refresh. It will do it in the 2-color demo. That does also work for this display, and there it will also refresh a little bit faster as it has another lookup table. This is now just some demo running, showing the capabilities. We can also remove this white sticker around the display. This will make it a bit more technical looking, but it will also remove the barcode here. Maybe we can even remove that, but I don't think without good results, but it's not too bad. We have a little bit of glue stuff left, so we could even remove the barcode. So this is it so far for this how to solder wires to the e-paper PCB. I have already opened up the design for this e-paper or e-ink PCB adapter. This would make it easier to create such a PCB. But the hard part on this one is to solder on the 24-pin FPC connector. This is not needed on the hacking method, I would call it. But both versions can be used. The display itself is to 90% compatible to the WaveShare display. We have here another one where I will show the flex cable connector, and you can see here that the upper part has the flex hardener and the lower part has the gold contacts. On the WaveShare display, this is on the other side. So their adapter PCBs or connectors are not like this one where the contacts are on the lower side. On there the connector contacts are on the upper side of the connector, so they do not work. You would need to replace the connector with another one if you have a WaveShare PCB or adapter or anything like that. Okay, wish you a great day.